So far we've learned 4 area formulas. Today we're going to learn one more. The formula we're going to learn today is the area of a regular polygon. A regular polygon is a polygon where all the sides are the same length and all the angles are congruent. The formula for the area of a polygon, a regular polygon, is 1/2 times capital P times lowercase a, where the capital P stands for the perimeter of the figure and the lowercase a stands for the apothem. The apothem is kind of like the radius of a regular polygon. It's going to start in the center of the regular polygon and it's going to connect to the midpoint of one of the sides. This formula works for all regular polygons. If we have a regular triangle, the apothem connects to the midpoint of one of the sides. If we have a square, a regular quadrilateral, the apothem connects to the midpoint of one of the sides. If we have a regular pentagon, the apothem connects from the center to the midpoint of one of the sides. If we have a regular hexagon, the apothem connects from the center to the midpoint of one of the sides. In example 1, we're going to use this formula to find the area of the figure. To use this formula, we first need to find the perimeter. In this case, we have an equal angular triangle, and if we have an equal angular triangle, we also have an equilateral triangle, which means that this is a regular triangle, which means that all of the sides are 10 long. So my perimeter is going to be 10 plus 10 plus 10 for a grand total of 30 units. The area, we're going to use this formula. 1/2 times the perimeter times the apothem. So we're going to have 1/2 times 30 times, we need to figure out this apothem. To figure out the apothem, we're going to have to do some problem solving. I'm going to first draw in the apothem. There's the center of my triangle, and I'm going to connect the center of the triangle to the midpoint of one of the sides. When I connect from the center to the midpoint, that is my apothem. Now to figure out this apothem, I'm going to draw in this length from the apothem to the vertex of one of the triangles. The reason I want to do that is it creates a right triangle. And in this right triangle, I know that the length from here to here is going to be half of 10, so this length is going to be 5. I need to use that to figure out the rest of the sides of this triangle so I can figure out this apothem. Well, to do that, again, I have to do some problem solving. I know that this triangle is equiangular, and there's 180 total degrees, which means that each one of these angles is 60 degrees, because 180 divided by 3 is 60. And if this angle is 60 degrees, when I draw in this length right here, this angle right here has to be half of that, 30 degrees. So in this triangle right here, I have a 90-degree angle and I have a 30-degree angle, which means that this angle right here has to be 60. So in this example, this angle right here, 30 degrees, is half of my entire angle. I have a right angle, 30 degrees, and 60 degrees. So I'm going to use the rules for my 30, 60, 90 special right triangles to figure out the length of my apothem. In this example, 5 is my middle length. To go from the middle side to the shortest side, my apothem, I'm going to have to divide by the square root of 3. So in this example, my apothem is going to be 5 divided by the square root of 3. Now I need to simplify this answer. To simplify, I need to rationalize my denominator. And I end up with my apothem being 5 square roots of 3 divided by 3. A couple things I need to point out. This apothem is not half of this entire length. It doesn't work out that way. It's actually only a third of the entire length. So don't think you can take this entire altitude and just divide by 2. That's not correct. Don't think that this entire altitude is going to be 10. This entire altitude is actually 5 square roots of 3. Now I'm going to take this apothem and I'm going to plug it into my formula. At this point, I could take out my calculator and do this math, but I'm going to show you a shortcut to multiply fractions. I'm going to put 30 over 1, and I'm going to leave everything else the way it looks as a fraction. To do this math in my head, I have multiplication, and any time that I have a number in the numerator and the denominator, I can simplify. So if I look, I have 30 and 3. 30 and 3 are both divisible by 3. So if I take 30 and divide by 3, I'm left with 10. And if I take 3 and divide by 3, I'm left with 1. Now I have a 10 in the numerator and a 2 in the denominator. 10 and 2 are both divisible by 2. So if I take 10 and I divide by 2, I'm left with 5. And if I take 2 and I divide by 2, I'm left with 1. So now, in my numerator, I have 1 times 5 square roots of 3, which is really 25 square roots of 3. And in my denominator, I have 1 times 1 times 1, which is just 1. And anything divided by 1 is just that numerator. So I don't even need to write it in there. So my answer is 25 square roots of 3 units squared. If you look, this should be the same answer that we got in the first example in 11.2. We started with the same triangle, but we used a different formula to get the same answer. In example 2, we also need to find the perimeter and the area. But to do that, I'm going to need to use this side of my triangle and problem solve to figure out my apothem, and then to figure out this length, which will give me my entire length. So the first thing I need to look at is the fact that I have a pentagon. And just like in this equilateral triangle, I need to figure out how big this angle is. Well, in a triangle, it's easy to figure out. It's 180 degrees divided by 3. In a pentagon, I'm going to want to use the formula to find the measure of one interior angle. From Geometry 1, the formula to find the measure of one interior angle is the number of sides of the polygon minus 2. If If you remember, this tells me how many triangles fit inside my polygon, times 180 degrees. That's how many degrees there are in each one of these triangles. So when I multiply this times this, that'll tell me how many degrees I have total. And then I'm going to want to divide by the number of sides. And if I divide by the number of sides, that will tell me how many each angle is worth. So if I take 5 minus 2, that tells me that if I start at one vertex and I draw in all the diagonals from that one vertex, there will be 3 triangles inside that pentagon. Each triangle is worth 180 degrees. So I have an interior sum of 540 degrees for a pentagon. And since this is regular, I can divide by 5. And each one of these angles then is worth 108 degrees. So if this angle is 108 degrees, this angle right here is going to be half of that. Half of 108 degrees is 54 degrees. Now in this triangle, I have my apothem, and I have a segment drawn in from the center to a vertex, and then I have half of one side. And I know that this angle is 54 degrees. In the first example, I ended up with a 30, 60, 90 triangle, so I could use the formulas, the patterns, for a special right triangle. In this example, I don't have a 30, 60, 90 triangle or a 45, 45, 90 triangle, so I'm going to have to figure out these lengths using trig. So I need to figure out my apothem and this side. If this is 54 degrees, 3 will be my hypotenuse, A will be my opposite side, and X will be my adjacent side. So to solve for A, I'm going to use sine. Sine of my angle, 54 degrees, is going to equal my apothem, the opposite side of this triangle, divided by 3. Cross multiply to solve for A. I get A equals 3 times the sine of 54 degrees. And I can use my calculator to approximate trig. A is approximately 2.427. To figure out X, I'm going to use cosine. Cosine of 54 degrees equals my adjacent side, X, over my hypotenuse, 3. Put this over 1 and cross multiply. X is going to equal 3 times the cosine of 54 degrees, which is approximately 1.763. I should have enough information now to finish the rest of my problem. If X is 1.763, this entire length is going to be double that. The apothem always connects to the midpoint of one of my sides. So I'm going to take this number and double it. So that means my perimeter is going to be 3.526 times 5. I have 5 sides in my pentagon, so I need 5 of these lengths. Now, I started with decimals in this problem. I had to use trig to solve for my apothem. I can have decimals in my answer. My area is going to be 1/2 times my perimeter times my apothem. 1/2 times 17.63 times my apothem, 2.427. I can use my calculator to approximate that answer. 1/2 times 17.63 times 2.427. My rule of thumb is, if I start with a decimal, I can have decimals in my answer. If I don't start with a decimal, I need exact answers. So in problem number 2, in order to figure out the apothem, I figured out this angle, and then half of it was 54 degrees. 54 degrees told me I have to use trig to figure out my missing sides. In example number 1, I figured out this angle, and then half of it I ended up with a 30-60-90 triangle, which meant that I could use my rules for a 30-60-90 special right triangle to figure out my apothem, and then I could get my exact answer.